Hello everyone, my name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Okay, today I would like to explain about the work holding devices mainly in lathe machine. So what are the different work holding devices which are used in or performing the machining operation mainly on lathe? So this is the course outcome. At the end of this course, students should be able to explain the operational principles of different lathe machines and various reciprocating machines also. Lathe machines and reciprocating machines for the quality machining, quality uh, good uh, machining. So we'll see what is work holding devices. Holding of the work or work pieces rigidly uh, on lathe machine. We already discussed in previous classes what are the different types of uh, operations. To perform any operation, the workpiece should be hold between the live center and dead center. Uh, should be fix this one very rigidly, uh, uh, very strongly. So otherwise, some leads to some or rough finishing or rough surface machining occurs. Okay, work holding devices are the device that is using to hold and rotate the workpieces along the spindle. We know that in previous class also we discussed that the spindle which is attached to the headstock, it provides the speed or rotating motion to the workpiece. Okay, so to held the or to hold the workpiece between the live center and dead center, there are some work holding devices like checks or mandrels, so some plates, dog plates. Okay, so different types of work holding devices are there to hold the workpiece between the live center and dead center. Okay, different work holding devices are using according to the shape, based upon the shape of workpiece and size of the workpiece and the length of the workpiece and the diameter of the workpiece. So based upon these dimensions, so there are so many different work holding devices are available or accommodated to hold the workpiece between the live center and dead center. Okay, we'll see. These are the just like we know the specifications of the lathe. We know that to okay. So as for the specification, we can just different sizes of lathes are available in the market or workshop. Okay, so size of the lathe is specified as follows. Okay, the first one is the length between the centers. So that shows there is a particular mm, length between the live center and dead center. So maximum length, possible length. So this is the live center, this is the dead center. Okay, so based upon this size, we can hold the workpieces between the live center, dead center. So maximum length of the job that can be mounted between the centers. So it means so live center and dead center. So which is the maximum allowable length to be fixed to the whole or to be fixed the workpiece between the live center and dead center. So that is the length of centers. Okay. It is depend upon the size of base or size of the lathe machine also. So next one is the length of the bed also. Okay. So this gives approximately floor area that the length can occupy. Okay, so based upon the area which is covered by the lathe or a lathe bed, so that that shows the length of bed. Next, height of the centers also. Okay, so it is measured from the lathe bed. Okay, so by lathe bed to just like the axis between the live center and dead center. So this is the, you can assume this is the height of the centers. Okay. So next one, maximum diameter over a carriage. Okay, so maximum diameter over a carriage. So this is the diameter of the work or bar, so that may pass through the hole of the headstock. So you know that left side of lathe machine headstock is there. So on this headstock we can fit, you can fit the workpiece. So up to based upon the this mainly the size of the centers or height of the centers. Okay, okay, there is a just like there is a particular allowable diameter, so through which the okay, we can see, so maximum diameter over a carriage, that is the just like this is the diameter of the work or bar, so that may pass through the whole of the headstock spindle. So you know that this is the headstock spindle. Okay, headstock spindle. So through which so it may pass through the hole, uh, just like, so it allows a certain diameter. Okay, so that is the maximum diameter of the carriage. Next, swing diameter of the bed also, maximum diameter of the workpiece or work that may revolve over the bedways. So you know that, so this is the guideways on which left side is headstock. So this is the right side is the tile stock. So this is the live center, this is the dead center. Okay, so uh, the swing diameter means so the space between the just like live center to the axis between the live center and dead center to lathe bed guideways. Okay, so the maximum diameter of work that may revolve. So just like center point of workpiece or axis of the workpiece to the guideways. Okay. Beyond this radius we can't just allow the uh, workpieces to hold between these centers. Okay. So next one, the swing diameter of the carriage also, that is the maximum diameter of work that may rotate over the chandle also. So this is the just like different specifications of lathe. Okay, so based upon the specifications and based upon the size of work to be performed, we can choose the different specified lathes to perform the machining operation on different varying sizes of the workpieces. Okay, now we'll see work holding devices. So you know that work holding devices are the device that is used to hold the workpiece, and it also provides the rotating motion or rotating the workpieces along the spindle. Because spindle will rotate, so automatically the workpiece is attached to the spindle. So simultaneously the workpiece also rotating with the spindle, rotates with the spindle. Okay, work can be held on a lathe by the following ways. Okay, so uh, workpiece can be held between the centers. You know that the centers, so live center and dead center. So, like, so like we just like work can be held or workpiece can be held or can be fixed between the centers and driven by just like catch plates or carriers also. Some on the headstock position we'll use some plates to hold the workpieces. Okay, sometimes we can checks or some mounting plates, we can use that one. So next one is the work held in checks also. Will here we'll use the check we know that universal check or 4J check based upon the dimensions of the workpiece. We'll prefer those checks. Okay, work can be held between the checks. Next, work can be held on face plates. So face plates also can be used. We'll see one by one. So next, work can be held on the angle plates. So just like for the performance operations on just like elbow shaped objects. So for the just like mounting or holding of this type of workpieces to accommodate the uh, uh, accommodate uh, to perform the machining operation, just like we will use some angle plates. So by the help of the angle plates, we can provide this surface against the workpieces. Okay. Next, work held on mandrels also. Some types of mandrels are there to hold the workpieces. We'll see one by one also. Next, work held in turning fixtures. So some types of fixtures are there. So by those fixtures, we can hold the workpiece between the centers. Okay, first we'll see work held between these centers. Okay, so here just like dog plate or a driving plate is there. So by using this one, this is the live center. So by using this plate, we can held the workpiece between the live center and dead center. So this is a just like one type of lever that is called dog. Just it is attached to the driving plate. So driving plate, it is just like we can camp the workpiece to the this dog. Okay, so by so it is fixed to the dog is attached to the driving plate. So the uh, plates rotates with the help of the spindle, automatically the workpiece will be rotated. Okay, so in this way, just like we can I can hold the workpiece workpiece uh, between the centers, so live center and dead center. So okay, here long shafts are generally held between this. So mainly this type of attachment, this type of uh, just a work holding system is used for the long bars. Okay, it's very long shafts to perform the machining operation, turning operation. So long shafts are generally held between this type of the centers. So here driving plate or catch plate is screwed to the nose of the headstock spindle. So this is the attached to the headstock spindle. Okay. So the live center is inserted into the headstock spindle like this one. This is the live center. It is inserted into the this piece. Uh, Live center inserted into the headstock spindle. Okay. So next to tile stock carries the dead center. You know this one. This is the dead center, so which gives the support to the workpiece. The workpiece is supported between these two centers. So this is the live center. This is the head center. Okay. So this driving plate is attached to spindle. When the spindle rotates, automatically the driving plate also rotates. So this to this driving plate, uh, workpiece also attached to the driving plate by the help of dogs. So automatically, if the spindle rotates, the driving plate along with the workpiece, just both are rotated. So then we can perform the machining operation, lathe operation, turning operations. So the driving dog is clamped to the workpiece like this one. Driving dog is clamped to the workpiece by screws. The tail of the dog or carry attached to the cast plates. So this tail is attached to the cast plate. So there is a connectivity between the rotating driving plate and just like workpiece. Okay. When the spindle rotates, the workpiece will rotate through catch plate and carrier. So by the help of the catch plate and the carriers, so workpiece will rotate. So and the workpiece rotates, automatically you can perform the turning operation. So this is the one type of holding devices. Now we'll see just checks we already discussed in previous classes also. Checks are very important to work holding devices. Okay, check is specialized type of clamps, okay, used to hold the workpieces. It has three jaws if it is universal jaw. Okay, universal jaw has three jaws. These when you operate this lever by the help of some levers, when you operate this screw, automatically the three levers will move simultaneously and fix the and holds the workpiece between these jaws. Okay, chuck is mounted on the spindle which rotates within the headstock. You know that. So in the headstock there is a hollow spindle. So work this chuck is mounted to the attached to the mm, this headstock. Okay, on the spindle to the headstock. So work held in the checks, we will see work of short length. Okay, works of mainly this is used for the short length objects, short length workpieces. So works of short length, works of large diameter also, and works of irregular shape. For the irregular shape, we will prefer the four jaw check. Okay. So there are four jaws, so we can operate each jaw individually. But in universal check, just like when we can operate three jaws simultaneously. So the check is attached to the spindle of the lathe. Okay. So the work is fixed between the jaws. So here jaws. Okay. And the jaws are tightened by the levers. Next, the right hand, the right head end, the right end of the workpiece may be supported by dead center. Okay. So this one is the check. So work held will be held in this check, and another end is supported by the dead center. So then machining operation will be performed. So next, this is the uh, gearing system to move the jaws. Okay, three jaw checks. It has three jaws. You know this one, like this one. When the check is turned by the some levers, all the three jaws will be moved equal distance at the same time simultaneously. Okay, so at the same time the three jaws will move equally. Okay, so and holds the workpiece rigidly. The work can be centered automatically and quickly also. So this is the main advantage of three jaw check. So it is used for the holding mainly regular objects like round objects, hexagonal or square type. Okay, rectangle, just like our regular shapes. To hold the regular shape, we will use the three jaw checks. So next to four jaw checks. So mainly it is used to hold the irregular objects, like because each jaw can be operated individually here. So by operating each jaw, just like as per the requirement, we can hold the different just like irregular shape, different shapes of the works. So it has four jaws. Each jaw can be moved independently. So key when the check key is turned in the slot, so that particular jaw will move to the required amount. So we can operate individual jaw by the keys, by this type of keys. Okay, the jaw can be reversed for holding the jaw. Sorry, reversed for the holding jobs of large sizes. So we can reverse it, just like these jaws are reversed. Uh, so in forward motion also it can be hold, and just like we can reverse it and we can hold the workpieces. So that is the accommodation is given here. Next, concentric circles are inscribed on the face of the check for the quick centering. Eccentric, just like machining, for this one we can use the independent checks also. So these checks are used to hold the large jobs and irregular jobs. That is the main advantage of uh, this device, to hold that type of irregular jobs. Okay, so next one is the magnet check. Okay, uh, so mainly used for the holding of the thin objects which are not possible to hold in the checks, are the just like plates, dog plates also. So in this case, just like we'll use magnetic checks. So when the pressure of jaws is to be prevented, because of if you apply the more pressure, just like the surface, the shape of the body sometimes may be damaged. So in this case, just like we prefer the magnetic checks. So check is used, magnetic checks are used. Check gets magnetic power by the help of the magnetic field. You know this one. So only magnetic barrier. So it means all the metals which are having the magnetic properties. So those metals can be held on this magnetic check. Okay. So next, call it checks. So these are also used to hold the bars of small sizes below 63 mm. It is normally used where mass production work is required. Okay. So mainly in capstan, turret lathe, and capstan lathe, or turret lathe, and automatic lathe also. So in this case, we will use the collet checks. Next, drill check also there. It is used for holding the straight shank drills. Okay, ramers also, or a tap for the drilling. So to fix this type of tools, just like we'll use the drill check. Okay, this may be held either in headstock or tailstock. So we can fix this type of drill bits, or ramers, or just like boring tools, by the help of the drill check, either in tailstock or headstock. Okay, so this has the self-centered jaws, is operated by the keys. So it has self-centered jaws. So we can operate those by help of the keys. So next to centers, or the different centers are there. Lathe centers are hardened steel devices used for the holding the workpieces to be turning operation. Okay, the center that is fitted in the headstock is called live center. Okay, so just like this one, the center that is fitted in the tile stock, so that is called dead center. So the center which is fixed in the headstock, that is live center, because machining performs, or machining will be done at live center. Okay. So dead center means that gives the support to the workpiece. Various forms of lathe centers are there. Ordinary center, ball center is there, tipped center also there, off center, revolving center, and pipe center, inserting type center. So many centers are there to hold the workpieces. Okay, so this is the one more, that is the work holding device. This is the face plate. This is very important. So on this face plate, we can fix the angular plates also to hold uh, like elbow sections. Okay, so to perform the machining, turning operation, this type of elbow sections require the face plate and the angular plates also. So those angle plates are fixed on the face plates. Okay, so uh, so it has some slots, and some holes are there to screw that angle plates on that one, or elbow systems on this one also. Okay, face plate is a circular plate screwed to the lathe spindle, attached to this lathe spindle. If the lathe spindle rotates automatically, this face plate also will be rotated. Okay, so many holes and slots uh, are there on the face plate. Okay, the workpiece is mounted on the face of the face plate. So by bolts, by the help of the, or clamps, or nuts, so through this, by using this slots and holes, we can fix that workpieces on this face plate. Okay, so spindle rotates. And the spindle rotates, so the face plate is attached to the spindle, automatically face plates will rotate, and the face plates will rotate, so that work which is attached to the face plates, that will be rotated. So large irregular heavy jobs, so for performing machining operation, turning operation on this type of jobs, we prefer the uh, this like face plates, where those types of the jobs which are not possible to accommodate or hold by the checks, regular checks are placed just like by checks. Just we prefer this type of devices. Okay. So next, uh, angle plates also there. So this is the angle plate, so we can fix this angle plate on the face plate. So by using this angle plate, we can fix this type of elbow shaped object to perform the turning operations. We can see all these things. Okay. So mantles also there. These are the another type of fork holding devices. It is used for the holding hollow jobs, mainly hollow type of jobs. Okay. Like this one, this is the workpiece. By using this mantle, we can fix on this uh, just like we can fix these workpieces by the help of the mantles to accommodate the uh, against to the tool bit. So workpiece is mounted over the mantle, and mantle is rotated between the centers. This is the center. Okay. So mantle will rotate. So the workpiece is attached to the mantle. So automatically the workpiece also will be rotated by the help of the mantles. So you can perform the different operations. The outside diameter of the mantle should be equal to the inside diameter of the workpiece. You know, this one, this one, this one. So different types of mantles are used in this one. Okay. So you can see different types: solid mantles, gang mantles, and expanding mantles, or core mantles also, screw type mantles, step mantles also, collar mantles also, different types of mantles. So by using this one, we can fix the workpiece on these mantles, and we can perform the turning operation. So these are the different types of work holding devices. So these are the references to by just like so if you have any doubts, just you can go through these books, and then you can understand properly. Thank you for listening this class. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.